Hello everyone, I'm Ganesh studying in Sri Venkateswara College of Engineering. Today I'll be explaining about the subject research methodology concerned about the topic next generation traffic control adaptive timer and emergency vehicle priority in intelligent traffic management system. So why is basically this traffic being always been a hectic or headache to us? So first thing, how to improve the traffic flow and emergency response using this technique, that is adaptive timer and emergency vehicle priority, will be discussed. So first thing, what are the challenges in traditional traffic system? So first thing is rigid timing. So here there is no fixed traffic time. Signals cannot adapt to the changing traffic patterns and volumes throughout the day. That is when we travel from a place to place, we often see that the places that are covered or the opposite lane which is present will always be free when we are traveling, and that is the most concerned thing that everyone will be concerned. And that timings, and during the peak hours only there will be much more traffic, but after that the traffic reduces, but the waiting period of the signal that will be fixed has to be maintained, such that even when there is no traffic also people have to wait a lot of time, have to wait for a longer period of time in the signals. Second thing, congestion and delays. So first thing, that is inefficient signaling timing will lead to longer times and increased fuel consumption and also some environmental impact. So what is this longer waiting times? Again, comes back to the same old point that when congestion is nothing but waiting in a queue for a longer period of time. So here, if we get stuck in traffic, there is chances that we have to wait a very longer a period of time, and during that period of time there may be so many important works that has to be held, or also it might be disturbing our mental peace, and so on concerns will also be raised. Next thing is increased fuel consumption. So while we wait in the traffic, we're not so much concerned about just turning off the vehicle when it is not using. The only thing we are concerned is about just to reach the destination, and let it take how many minutes of time. We are not uh, con- uh, con- uh, we are not thinking about what is the fuel consumption that the vehicle will be taking up, and also the environmental impact. Due to this traffic congestion, what will happen is environmental impact, that is pollution will become more, and also if there are some apartments that is present nearby to the roadside, then those also have to be those people present there also have to play some vital roles, when like they get disturbed, or some other noise pollution might also occur. Not only a pollution, that is air pollution or noise pollution, there might be some harmful pollution, that is the gases getting released into the atmosphere, and also other things. Emergency response challenges. So here, in this modern techniques what we have adapted ourselves, there is no emergency vehicles prioritization that is given by by the vehicles or even by the government. So even it is an emergency vehicle, it has also has to follow the same things, and it will cause delay in more and more critical situations. So what is this adaptive traffic signal control principle? So here, what is adaptive control traffic signal is nothing but it is a real-time optimization and integrated coordination of both predictive algorithms and available information to gather the data and continuously keep updating things. So, what is this adapting timer is? It is the dynamic adjustment of traffic signaling timings, and also it will optimize the traffic flow, and also it will reduce the congestion. So this integration will be basically done with IoT sensors and cameras, and most of the algorithms will also be used in performing the same. So it is the traffic signal timings in which real time to optimization traffic flow, reduce congestion, and also to minimize delays. So what are the key components of this adaptive traffic signal controls are, first thing is real-time traffic management or monitoring. So here with the use of sensors and cameras, we can collect the traffic data. Second thing is using the algorithm, so we can analyze the traffic data and also adjust signal timings. Third thing is communication network. So here the real-time data exchange between the sensors, algorithms, and traffic signals will also be possible. What are the technologies that will be implemented with this adaptive traffic signaling is one thing that is basically done as artificial intelligence, machine learning, internet of things, cloud computing, and data analytics system. So all these technologies will be used with this adaptive timer to efficiently collect the data and also provide useful information to the users. So what are the benefits is to reduce the congestion. It will improve the travel time, that is to travel certain distance. The time required will certainly be low. And also the next thing is safety is also enhanced. Next thing, efficiency of the vehicle, and also that is by reducing the fuel. Last thing but not the least, it is the air coming to the air quality, that the air quality can be bettered by itself. And next thing, emergency vehicle priority functionality. So what is this emergency vehicle priority functionality? Is nothing but it is a technology that will enable emergency vehicles to receive priority at the intersections and traffic signals, reducing response time and improving safety. So what this basically do is, first thing, it will if there is some emergency vehicle. So the first step that is present here is detection. So there are n number of sensors and communication systems that will identify approaching whether there are any approaching emergency vehicles. Second thing is signal prioritization. So there will be algorithms dynamically built to adjust signal timings to create a clear path for emergency vehicles. The third thing is real-time response. So here the system will coordinate with the intersection of the nearby sensors, and also to ensure the uninterrupted passage for the first responder. So how will these be done? So first thing, in the detection stage, sensors and cameras will detect the approaching emergency vehicle. In the second stage, that is a communication and signal prioritization. So here the real-time communication between the emergency vehicles and traffic management center will be done. And for the prioritization, so here the traffic signals that are present will give priority to emergency vehicles. The last thing is route optimization or real-time response. So here, which is the better route, that is dynamic routing systems will be adopted, and also this will enable the smooth functionality of the emergency vehicles. So what are the technologies that will be basically used in this emergency vehicles priority functionalities? First thing is GPS and automated vehicle location, and dedicated short range communication, cellular networks, IoT sensors and cameras, and artificial intelligence and machine learning. So what are the benefits that will be obtained from this emergency vehicle priority functionalities? So we can reduce the response time of the user, it will improve the safety, and also emergency response is more, the efficiency consumed is also more, and next and the last thing is the traffic management can be done in a better way. So what is this integrated system architecture? So here there are three basic steps that will be discussed. That is the sensor integration. So what is the advanced detection technologies and monitor traffic control and emergency vehicles movement. And next thing is data analytics. So real-time data processing and predictive algorithms will optimize the signal timing and emergency response. Network connectivity will secure the low communication links, that is enabling coordination between the intersection of all these devices. So here in this architecture, it is not only about the sensor integration, data analytics, and network connectivity, but also have to check whether the functionality of all these sensors that is adapted is proper, and the analytics what we get from all these data is also properly managed or not. So what is the sensor integration and data analytics? So there is three basic steps, that is adaptive sensing, data-driven decisions, and emergency vehicle tracking. So what is this adaptive sensing? So here advanced sensors will continuously monitor the traffic volume, speed, and patterns to enable real-time adjustment. Data-driven decisions, that is algorithms that will be used, will leverage the historical and real-time data to forecast the traffic condition, and also the signal, optimize the signal controlling and timing. So emergency vehicle tracking. So here the sensors and communication systems will detect and prioritize the movement of emergency vehicles so that the movement of these vehicles will happen in a better way. So what is the evaluation and performance of these particular things is deployment, data collection, and performance analysis. So first thing is, if the system has to be implemented, then we have to surely deploy it. So this will be implemented in a high traffic urban area to test its effectiveness. Data collection. So here continuous monitoring of data patterns will be done. Emergency response times and user feedback will also be taken at the same time, and the performance analysis will be done on the key metrics that will include that is including the reduced congestion, improved emergency vehicle prioritization. So what are the conclusion that is obtained from this topic is, first thing, adaptive traffic control. So here the system that is present will significantly demonstrate the improvements that will happen in the traffic flow and emergency response time. The second thing is intelligent integration, combining adaptive signal timing and emergency vehicle priority, unlocking the full potential of intelligent transportation. Continuous innovation. So here there are researches and developments that are continuously happening that will further enhance the system's capability, such as integrating with autonomous vehicles. Thank you for watching.